The algorithm that we are going to study today is a binary search algorithm. The last time we studied linear search algorithm, which was a sequential search algorithm. This is the next category of searching algorithm called as interval searching algorithm. So basically, in this type of algorithm, there's a specific interval that we look in for the target element. It is also called as half interval algorithm because we divide the array into two parts, or it is also called as logarithmic search. These reasons you will understand after we discuss the algorithm. Why is it called half interval and logarithmic search algorithm? First we'll take a simple example, a real life example, how we use actually binary searching algorithm without even knowing it. Consider a phone book. So you want to find a number of, let's say, of a company named Oracle. So Oracle starts with alphabet O. So we don't start searching for the Oracle from the first page. What we do, we randomly split the book in half and we see where are we. We check if we are, let's say if we are at alphabet M. So we know that we have to move right because O will be afterwards. And if we see we are at the element, let's say W, we know we have to go on the back side, we have to go on the left. The same logic is used in binary search algorithm. Rather than comparing element one by one from one end, how about we directly dive in and go in the middle and see if that element is bigger than the target we're looking for or less than. But in order to work that, because in linear search, the list was unordered, it was not sorted list. So we had to go one by one. Binary search will work only if the list is sorted. So if we have the sorted list, just like this one, let's say, it starts with 2 and last element is 4 and 1. Every element at lower index has lower value than the element at higher index. So when the list is sorted, we can use this searching algorithm rather than comparing one by one. Like in phone book, all the numbers are sorted with their alphabet. Okay, so if we discuss binary search algorithm, there are two steps that we need to follow. First, we calculate the mid element. So we have the length of the array, the starting and ending point. Using those, we calculate the mid of the array. Then we compare the target element that we're looking for with that mid element. If the value is less than the target, then we narrow the search to the lower half, that is in the first half of the array. Otherwise, we move into the other half of the array. This algorithm works why? Because we know the list is sorted. So the middle element, if it is less than our target element, it means all the elements in the left part are obviously lesser than the mid element. So there is no point in going in that half. So that way, we can, by every step, we can remove the half of the array and we have to only search in the other half. So like in linear algorithm, we were comparing one by one. In this, we simply skip the half of the array in every step. Let's go. We'll see an example. Let's say we have this array of length 12. Index starts from 0 to 11. So first what we need to do is we need to calculate the mid. So mid will be calculated using this formula L plus H minus L by 2. L is low, H is high. So in this case, L is 0, H is 11. So the mid will be 5. When we go to the index 5, we see the value is 97 and the target that we are looking for is 17. The value and target though do not match, but let's compare. The target is less than 97. Okay, so we do understand the target is less than 97, so we have to move on the left side of the array. So what we do in the next step, we ignore the right side. So the right half of the array is ignored. Now we'll only focus on the left half of the array. How do we do that? We move the high index from 11 to the mid minus 1. So basically we are ignoring this part. So this part is ignored and the high index is moved to this part. Now we repeat the same process again. Let's calculate the mid. So mid will be left plus H minus L by 2, which would be 0 plus 4 minus 0 by 2, which is 2. So this will be mid. In that case, the value is equal to 11. The target that we are looking for is 17. They do not match. Okay, so what can we do? We compare the values 11 and 17. We see the target is more than our value. That means what do? We move on to the right side of the array. So now this was the array, this was the mid. Because the target is higher than the element we have at the mid, we go to the right side because all the higher elements are on the right side. So we ignore this part. So here we mark these parts which are ignored. How do we ignore this part? We say our lower boundary is not from here, we move it to here on the third index. So this is lower and this is higher. We do the same process again. We calculate the mid. That will be 3 plus 4 minus 3 by 2, which is 3 plus 1 by 2. Because it will be 0.5 and there cannot be an index 0.5, so we consider as remainder 0, so it will be 3 only. So now we go to mid. The value at mid is 17. The target that we are looking for is 17. They match, so we return the index 3. In this case, what we need to focus on, the number of comparisons we have performed. So what did we do? We first find the mid of the initial array, that was 5. This was the mid, so there was one comparison. Then the second round we went and compared the mid of the left side of array, the left half that we had, that was here, and the third was this point where we calculate the mid again. And so basically we calculated the mid and compared it with the mid, so it's the third comparison. So basically if we need to find an element, what we do, we find the middle, we split the array in half. So that's why it also known as decrease and conquer. There's an algorithm category that you must have heard, is a divide and conquer. It is similar to that, decrease and conquer. It is kind of dividing, but we are not using the other of, so we'll call it decrease and conquer algorithm. And that the also reason that we are every time we are dividing the half the array size, that's why it's called half interval. Moving ahead, we'll see why it is called logarithmic search algorithm. First we'll see the iteration method, where we use the loop. It could be a for loop, it could be a while loop, whatever you need to use. So the function will look something like this. There's a binary search method that is written. It will take input as 4 values: the array, the input that we have given, the target that we are looking for, low and high, the index. So by in start we'll give low as 0, high will be the length of array minus 1. So basically the highest index in the array. What we do, we loop till low is less than equal to high. So low is 0, length in this case was 11. So 0, 11. So 0 is less than 11. So we go inside, we calculate the mid that we calculated in the element and we got it 5. We check if the mid element is equal to target. If it is found, then we return the mid. Otherwise, we check if the target is greater than array of mid. So if the target is greater, then we have to move on the right side. So we move on the right side. How do we move on the right side? We move the lower pointer to the mid plus 1. That's where we see this part here, that we went to mid, we found 11 and the 17 was higher than 11. So we move the lower pointer to mid plus 1. So the lower changed from low index to 0 to 3, so lower pointer. Otherwise, we move the high to mid minus 1. So we know if it is on the right side, then it must be on the left side of the array. So how do we do that? We move the pointer of high from mid minus 1. So basically it was, in this example, it was pointing at 11th index. But because our target was less than 97, we moved the higher index to mid minus 1. So higher came from 11 to 4. As every time the array is divided into 2 parts. So let's say in the first iteration it has 11 elements. In the next iteration it was looking only for 5 elements. And in the next iteration it was looking only for 2 elements. So what do we see? Every time the size of array is divided by 2. So let's say if we have 8 elements. So in the first iteration, if we have 8 elements, in the second we'll have only 4 because we'll either use the left half or the right half. In the third iteration we'll have only 2. In the fourth we'll have 1 and we'll find the answer. This pattern is basically a log n pattern. When the every time the number is divided into half, we call that pattern as log n, that is base 2. And the auxiliary space that we use for this particular algorithm is O of 1 because it's a constant space we are using. There is no dependency on the size of input. The low, mid and high, these are 3 variables that we are using that are constant. It doesn't matter if the size of array is 10 or 10,000, we use the same pattern. Other than iteration method, binary search can also be performed using recursive method. In recursive method, we have the same input as we took in the iterative method. We have the binary search method that takes array, target, low and high as input. The same base condition is here also. If low is greater than high, we return -1, that the element could not be found. Otherwise, we calculate the mid, that is low plus high minus low by 2. So if the target is equal to mid, we return the mid. Otherwise, if target is greater than mid, then we know that we have to move on the right side. So how do we do that? We change the lower pointer to mid plus 1. We move the pointer lower to mid plus 1 and it calls again the same method. Otherwise, we know that the number must be in the left half, so move the higher to mid minus 1. So basically, we move the higher pointer to the mid minus 1. Let's take an example how exactly it would work with the other example. So the example that we had in the early part of video, we'll see that array, we had this array. So the first search will be array, that entire value with 17 as the target, 0 and 11 as the lower and high. Then we go inside, we find the mid, that was we found at 97. We compare and we see that it must be on the left half of the algorithm, left half of the array. So we change the high pointer to mid plus 1, mid minus 1. So basically, we change it 5 to 4. Then we call again binary search method. So again we start from the binary search method definition. We calculate the mid and we find if the mid element is greater than the target or is less than. Accordingly, we again change the value. So in this case, we find the mid value was 11. So the target 17 is greater than 11. So we change the lower value to 0 to 3. We added mid plus 1 basically. And then here in this iteration, we find our value and return the mid. The time complexity is same of log n because every time we are doing the same thing, we are dividing the array into 2 parts. What is the auxiliary space? So in case of iterative method, we were using O of 1 space. But in case of recursive method, why is it O of log n? It is because every time you are calling binary search method from within the system, you are passing entire array. And because the size of array is reduced every time by half, so every time you're calling, so like the first time when an array was called, it had 12 elements. The next time it was called, it has only 6 elements. The next time it was called, it had 3, then 2, then 1. So basically, the space also follows the log n pattern. So auxiliary space is also of log n because we are passing that array every time to itself. So here we studied 2 methods, the recursive method to implement binary search and the iterative method. We also studied how exactly binary search works. What are the more things we need to know about binary search? We move on to the remember part. The first thing that we need to remember, binary search works only on a sorted list. So if your list is sorted, then only we can assume that if the mid element is higher than the target, then my target must be in the left side. Then the time complexity is big O of log n and the space complexity of 1 if you are using iterative approach and O of log n if you are using recursive approach. The binary search algorithm will not work for the multi-dimensional array because here every time we are splitting the array into 2 parts. So splitting the multi-dimensional array will not be possible. We can use binary search algorithm on only one-dimensional arrays. However, linear search was applicable for both one-dimensional as well as multi-dimensional array. We move on to next thing. What are the applications of binary search algorithm? The first application is dictionary. Just like phone book, dictionary also has all the words sorted in alphabetically. So when we need to find any word, we can use the binary search algorithm and find the word very efficiently. Next is debugging. So in all the high level language like Java, C or C++, when you encounter any error, the system itself uses binary search algorithm to find out the line where the error occurred. Third, many libraries of Java, .NET, C++, many other programming languages, internally they use binary search to find out the elements. Okay, so we understood the point that binary search is efficient because it divides the array into two parts. Then would it be better if we divide the array in three parts? What if we went ahead and we performed a ternary search rather than dividing the array into two parts? Let's divide in three parts. Would that be better? That would be a question to think that we'll see in the next lecture. Till that, remember there are two categories of searching algorithm. There is sequential and then there is interval. This is basically a linear search algorithm and this is binary, and there are other variations that we will study moving ahead. So thank you, and if you have any questions, feel free to comment them down, and if you have any help from this video, please consider subscribing to the channel.